Alright everyone, so in these last set of week's videos we are going to cover several topics. The topics are going to include first and foremost iteration approaches. In other words, finding an exact solution numerically for a complex equation. We did this in Excel where we did the f of x, where we did the methods where we said f of x is equal to 0 and pretty much finding the zeros or the roots of that function for that. So that's what we'll cover today in this video. Then we'll cover a video on optimization, one on integration and differentiation, and then finally we'll end with numerical solutions of ordinary differential equations, which we covered in class on Thursday, and we'll have a video on that as well. But to start with today, I'm going to cover how we do finding for complex equations the zeros of that. And if you've noticed in MATLAB so far, anything that uses a function, any function that can use a function, usually has an f in the front of it. So in this case, if we want to find the zero for a function, we are going to use f0. Very creative and clever approach to this. Now there's two ways we can find zeros, one for polynomial and one for any function. And the f0 approach is really just for any function finding the zeros. So let's go to our command window and give you an example of this. So let's create a function. I don't know, let's give, and we can create any function. It can be an m-file function or it can be an anonymous or a function handle function. Doesn't matter which way you do it. So let's say we want to do our function, which is going to be called Betty, is going to equal to at r, and what a function we can use. R is just our variable unknown, and we could say r of, I don't know, r dot times the exponential of negative r minus 10 or minus 10 times the sine of r. Okay, that seems reasonable. That's a function. Let's see how Betty works. Betty 10. We got an answer. Great. So let's find out how this function behaves, and let's see if we get a value for it. So if we want to know the answer of when Betty is equal, the output is going to equal 0, all we need to use is f0. F0's command is we give the function handle, and you can see here it actually tells you what to say. You're going to enter in your function, and then you'll also enter in your starting guess, your initial guess. You have to always make an initial guess, and it's going to, just like with in Excel, it's going to converge to a solution if it can. So let's give an initial guess of Betty, and we'll say the initial guess is 10. Hit enter, and we got an answer of 9.42747. Let's see if that's valid. So we can say Betty of our answer, and we get an answer that's very close to 0. That's very nice. I'm curious to see what this plot looks like. So if we did f plot of Betty from our limits from, say, 0 to 20, and plotted it, what do we get? We get a nice function that's actually cyclical. So we have one answer that is near 10, and that's what we had. But we should probably also have another answer that is going to be somewhere else. So, and obviously it's always going to converge to the nearest 0. So if I said 0 here as our answer, it's 0. But if I said 4, it'll converge to 3. So just realize, again, just like with the numerical methods in Excel, f0 is limited by what it can converge to based upon its answer. Now, one thing to note, and one thing I'll point out here, is that this f0 convergence is going to be based upon, or the function call in f0 for a function handle like Betty, where we have the function defined here. You can just type in Betty and you'll get the answer. If we created a function file, we would have to put an at in front of the name of that function, and then type in the function, and that'll let MATLAB know that whatever that function is that you've created as an mfile function is actually a function, and it's going to use that as such in that call. So just realize that. And so the one other thing, all right, jump cut, but just one other thing I wanted to go through into this file, or this looking for iterative solutions to complex functions. The Fzero will always work for most functions. You have to make a single guess, and it's only going to give you a single answer, right, to your nearest guess. Just realize that. But beyond that, the other classic case is where you have polynomials, and you have a higher order polynomials, and you want to know the roots of those polynomials. Well, there is a convenient function called roots, where the call is just roots c, where c is a coefficient of the polynomial. So in this case, let's say, for example, we gave a function f of x is equal to 10 to the 5th power minus 20.2 to the 4th power plus 3.35 x to the 3rd power minus x squared plus 10. Let's say that's our polynomial. So now, in this case, if we wanted to know the roots of this function, we'd have to first create a coefficient vector where it's just a list of coefficients in the polynomial from highest order to lowest order. So for this case here, we would say 10 minus 20 for the 4th position, 3.35 for the 3rd position, minus 1 for the 2nd order polynomial. You'll notice there is no x, so we'll have to put a 0 in there because x is 0 for the 1st order polynomial, and then 10 as our constant. And that's our terms. And so then all we would say is roots c, and we would get a table of our roots for this problem. So you can go here, hit that, actually enter roots, and you'll get a set of answers here. And you'll notice some of them are actually imaginary numbers, and some are real numbers in this solution of roots. But you'll get all of the roots to the equation, every value where the polynomial for this problem is actually to the where the solution is 0. So beyond that, those are the exact ways you can use and find this point where a function is equal to 0, or the function or the polynomial is equal to 0, and the conditions there is. So if you have any questions on this or any further questions, just let me know. And after this, we will go to our next video where we can actually figure out how to find the minimum and maximum of a function within a set of bounds. So we'll talk about that in the next one for optimization. So thanks a lot. Goodbye.